Welcome back to Is Unique. We've now covered 3 different ways to solve this problem. For the last method, we showed how to do it with both an object and a set. Now, you might be wondering why I showed you the set. It does the same thing as an object, and it doesn't really offer anything new. It's just another thing for us to learn and get used to. Well, I want to show you the true power behind a set, and I want to show you a way in which it can make our solution much simpler. So before we do anything, let's dive into some of the properties of a set. Let's just create a new one here. And let's throw in a few items. So we'll give it an array with the numbers 1 through 5. And let's log this out. So as you can see, when we give a set an array, it'll take each individual item in the array and add it into the set. Now, what was unintuitive, at least for me, was what happens when we give it a string instead. Oops. So let's go ahead and get rid of this and instead give it the string A, B, C, D, E. As you can see, what happened is each individual character in the string got inserted into the set one by one. The string essentially got split apart for us. This is very important. There's one more thing I want to point out, and that is the size property. So a string has a length property, which tells you the number of characters in the string. A set has a size property, which just tells you the number of items in the set. So as expected, it's 5, because we have 5 different items in the set. I want to show you one more thing, which is what happens if we add duplicates. Let me go ahead and add A, B, C again. And we run it, and we see that the output here is exactly the same, because a set, again, can only contain unique items, and the characters A, B, and C are already in there, so it completely ignores these 3. And the set contains 5 items, as we can see right here. Let's go ahead and go back to our problem. I'm going to erase all of this, and I'm going to write a line of code, and we'll talk about it right afterwards. That's actually the entire solution, and let me run this just to show that it works, and it does. Go ahead and test it out on your own if you wish. It'll work every time. Let's discuss why this is. As shown before over here, if we add duplicates into the set, they'll be completely ignored. That's what's happening here. We insert a string into the set, and each individual character is being inserted into the set. We're then checking to see if the size of the set is the same as the length of the original string. If there were no duplicates, then the size of the set should be exactly the same as the length of the string. However, if there were duplicates, then the set will be slightly smaller. By returning this comparison directly, we've solved the whole problem. If they're unique, this equality will be true, and the function will return true. If there are duplicate characters, this equality won't hold, and the function will return false. Again, let's go through the time and space complexity for this function. We're taking a string and we're adding it into the set, character by character. That's a linear operation. So it's O of n. Space. Again, we're adding each individual character into the set, so it's going to be proportional to the size of the string. So once again, O of n. Let's quickly wrap up by talking about everything we've covered so far. The first solution we came up with was the brute force solution that had an O of n squared time complexity. It's simple, straightforward, and it's the first solution that most people come up with. If you can identify the time complexity and then work to make it better, you'll ace this question in an interview. The second solution involved sorting the string first. It was better in terms of time complexity, but we had to increase the space complexity for that solution. The third and fourth solutions are ideal. We have the lowest time complexity, and we reduce it down to O of n, which is a very significant improvement. The fourth one here is clever, but the third one would have been more than sufficient in an interview. They both achieve the best time complexity possible. The main ideas to take away from this is that applying various techniques to a problem can significantly improve time or space complexity. Sorting our data brought down our time complexity, and then using an appropriate data structure, either an object or a set, improved it again. We'll see this popping up again and again. In the future problems, try using an object, array, set, stack, or queue, or any other data structure, and see if that opens up any new avenues for your solution. I'll see you in the next problem in the next video.